Okay, I guess where to start. Good morning, everybody. Thanks for joining us on the Cold Fusion Summit online webinar. My name is Nolan Irk. Today, I'm going to talk to you about adding web components to your CFML applications. Here's a little bit about me. I run South of Shasta. We are a developer consultancy. We build web and mobile apps for a variety of projects. Usually it involves Cold Fusion. Sometimes it involves other stuff. I also run a local tech meetup called SAC Interactive, where we talk about all facets of web and mobile development. I used to program video games before I switched over to the web. In addition to running South of Shasta, I have a small startup called FSK Audio, where we're building audio plugins. Speaking of audio, I'm willing to bet that I spend more time and money on concert tickets and record albums than the rest of you combined. My house looks a lot like this. I have music strewn all over the place because I'm quite proud of my record collection. If you want, just take a copy of, or take a photo of this slide here. That is my GitHub URL, and that is the name of the repository where all of the stuff we're going to show today is located. All of the code demos I'm going to show you, all of these slides, everything is up there now. So if you just want to save a screenshot of that, you can go look up the code and such later on at your leisure. That way you don't have to frantically take down notes while we're doing the webinar. I'll leave it up there for one more second so people can take a photo of it if they like. And here we go. All right, so prerequisites for building web components. You should have some comfort with modern JavaScript. We're not going to do anything crazy complex, but you should at least know basic concepts about like object-oriented programming. You know what a class does in general. You understand what a constructor does, how a class can have functions inside it and some variables inside it. That's about it, really. You should be familiar with the DOM in a browser, so you know what it means when an item is added to the DOM or removed from the DOM. You should be familiar with like event listeners, on click and on mouse over, and similar kinds of code. If you have any experience with Cold Fusion custom tags, I think just being familiar with that kind of syntax and that sort of concept structurally in your app will help with web components as well. And you do not have to have built APIs before, but if you at least know the general concepts of what an API does, how you hit a URL and that URL returns back JSON, usually that happens in some sort of AJAX style functionality in your app. That's all super helpful as well for web components. So today we're going to look at some basic examples of what web components are and some of the programming concepts and constructs that you'll use to build your web components. And then after a few demos of the ins and outs of how those work, we'll look at combining them with Cold Fusion in a couple of different ways. I will then give you some tips and point you towards some other resources that I have found helpful in learning web components myself, and hopefully they will do the same for you. So web components, they let you write your own HTML tags. These are the same as any other tag in your web browser, p, table, div, whatever. They are built in pure JavaScript. They work sort of like CFML custom tags, in that you have a custom tag.cfm file. You load that, and then you can call that custom tag using tag style syntax in your app. It's the same idea with web components, except whereas Cold Fusion custom tags are processed on the server, web components are pure vanilla JavaScript. They are processed in the browser, not server side. And vanilla web components, which is what we're going to look at today, they are pure vanilla JavaScript. They do not require any extra libraries or other add-ons of any sort. And because they are just small chunks of JavaScript, they generally run pretty fast. Web components are not framework specific. You do not have to be using Vue or React or Angular or Svelte or anything else to do them. They are just straight .js files, like the .js files you've probably been building in your apps all along. That being said, you can use web components with all of the JavaScript frameworks that are out there, React and Vue and so on. You don't have to. They work either with them or without them. If you do use web components with a framework, you do not have to change anything. The idea with web components is they are compatible with everything. They're just generic chunks of JavaScript. And of course, they work in Cold Fusion apps as well. So like I mentioned at the beginning, you should hopefully know a little bit about object-oriented programming, what a class does, what a constructor does, some basic things like that, and some general working knowledge of how the DOM behaves. You do not have to have Node installed. You do not have to have TypeScript installed or any of the third-party libraries. This is not a jQuery add-on. This is not a thing like Angular where you write code in TypeScript and it gets compiled into the JavaScript you'll actually use. None of those things that you might have had to do with other tech stacks in the past, none of them are needed for web components. You can just write .js files and you're good to go. And they can, of course, connect to any server on the back end, not just Cold Fusion, but if you also have like a Java server or a PHP server or anything else that sends JSON back to the browser, web components can talk to any and all of those. Browser support is pretty good. You'll see there's a tiny little bit of different color green here under Safari than the rest of them. There are 2 tiny bugs in Safari related to web components. The response on both of them basically from the Safari development team is, we know about those, but there are really, really good, easy to use workarounds that people have just been making part of their workflow, ever since web components have become a thing. So we're just going to let them continue doing that and not worry about fixing these. And honestly, that's been fine. I have not noticed any problems supporting Safari versus any of the other browsers. And with that, let's take a look at our first web component. So here I have an HTML file, and you'll see I've got a script file at the bottom, hello world.js, and in the middle I have a tag, hello-world. I want to go to load that up in my browser. It looks like so. Hello and welcome to Cold Fusion Online Summit. There we are. Now let's take a look at that JS file. This is my web component. A whole 11 lines of code, including all the white space that I have in there. So there's a couple of key things in here. We have class, hello world. It extends a thing called HTML element. We'll talk about that a little bit more in a minute. We have a function in here called connected callback. It's got 1 line of code, this.text content, and you'll notice that the text inside that variable is what appeared here on the screen in my browser. And below that, I've got this 1 line custom elements.define, where it's got the name of that class up there. And then on the left, I have hello-world, which is the name of the actual HTML tag that we used here in my HTML file. So this is my web component. And this is the line of code that basically makes that web component a thing that you can use in the DOM in your web browser. Basically, that's what lets you call it like any other HTML tag, like so. And that's it. There's no other files in here. There's a little bit of CSS just for kicks to color the text a certain way, but nothing about that is web component specific. Let's close those down. Back here and take a look at some other things. All right, so you'll notice that the naming convention I used in that example was hello-world in my web component. The hyphen is required in all of the web components that you make. The reason for that is to prevent naming collisions with future HTML tags they might add to the browser later on. It's like if in 10 years from now, if they make a tag called favorite color, all smushed together one word, if I make a web component that is called favorite color, all smushed together as one word, if somebody goes to my web page, the browser is not going to know, do we load the favorite color native tag baked into the browser, or do we load Nolan's web component called favorite color? So to avoid those collisions, the rule with web components is you have to have a hyphen somewhere in the name of your web components. So mine would have to be favorite color to differentiate it from the baked in one. Since you have to have the hyphen somewhere in there, what I usually recommend is come up with a naming convention for your web components so that they all have a similar naming style. You can tell real easily which web components are part of which library and that sort of thing. For example, I am not suggesting Adobe is actually doing this, but for example, if the Cold Fusion team had a set of web components they were working on, they might be named something like CF- and then the component name to make those all named in a Cold Fusion naming convention style. That extends HTML element thing at the top of our class file, this bit right here. That's also required. That is what basically turns your vanilla JavaScript class into a web component. That's the thing that says anything a basic HTML element can do in the browser, my web component can do as well. Technically, you can inherit from any actual HTML tag in the browser, table and div and paragraph and whatever else you want. That works fine in every browser except Safari. This is one of those 2 things I mentioned in the browser compatibility slide earlier. Technically, Safari will not let you extend straight from like a table or div. You have to extend from HTML element to make Safari stuff work properly. I have never run into a case where that's actually a problem. If you do build some sort of really fancy web component and you have to extend from, let's say, table, there are various shim JS files that people have written out there. You can find them on GitHub usually and work around that problem easily enough. So the JavaScript stuff, we have to do that extend HTML element. That connected callback thing in the middle that we have right here, that's also required. That is the code that runs when your web component is actually added to the DOM, basically when people write the tag style syntax in their HTML file and use your component somewhere. So you have to have that bit in there. And then that custom elements.define, that's the thing that actually says this web component will be named with this tag style syntax, hello-world, and please make it available in the DOM, just like any other HTML tag, paragraph, div, whatever. So we looked at connected callback. That one's for sure required. Technically, no, we did not have a constructor in the last example, but constructors in any OO language are generally a good practice. You're supposed to have a constructor in every class. I skipped it in that slide for two reasons. One, because technically you can, and two, just to make that demo for the first thing we looked at as small as possible so you can wrap your head around it easily enough. And there are a handful of other lifecycle methods that will do different things during the lifespan of your web component. Some of those we'll look at today, and some of those I'm just going to mention, and you can check those out in more detail later at your own pace if you want to. So the constructor, like I said, not technically required, but it is a good OO practice. If you've built CF components at all before, this is the same as the init method that a lot of folks use in their components. The naming convention is a little bit different in web component land, but it solves the same sort of problem. We'll look at those in detail in several of our upcoming demos. And connected callback, as you just saw, that's the code that actually runs when your component is added to your DOM somehow. These two methods, observed attributes and attribute change callback, they work sort of hand in hand. They are for if you have attributes in your HTML web components. Like if you have a table tag, you've got attributes like border equals something, cell padding, cell spacing. Those are your attributes. You can have your own custom attributes on web components. These two methods are what you would use to basically tell the browser, these are the attributes I care about, and this is the code that I want you to do, that I want you to run when those attributes change in some way. And we'll take a look at those too. Those are, of course, optional. If your web component does not have attributes, then you don't have to use these. We had connected callback, which runs when your web component is added to the DOM. You have disconnected callback, which runs when your component is removed from the DOM. You can do some sort of cleanup code there if you want. We're not going to look at that one in detail today. Another one called adopted callback runs when your web component is moved from one HTML document to another. I've looked around on the web a few times. I have not found a case when this is actually useful for anyone. The only thing I've seen mention of is people say if you have a website using iframes and you drag your web component from one iframe to another, this code would run when that event happens. If you are using iframes and web components to build a thing in 2024, I would love to talk to you after the session is done about why you thought that was the right plan for designing your app, because I cannot come up with a valid solution or a valid reason as to why it is a good solution. And I would love to learn more about what people are doing in that context. So attributes, they look like this. You have your web component, and then you just put your attribute inside the brackets, just like you would any other tag. And that is where we will take advantage of the observed attributes and attribute change callback lifecycle methods we looked at a minute ago. And with that, let's take a look at one of those demos. So here is my attributes demo. Here's my HTML file. It's pretty similar to what we had before, except now I have these first name and last name attributes in here. If I go into my JS file, pretty similar to what we had before. That's the same. We now have a constructor that just calls the super constructor to turn on the web component magic in our app. I set this.firstName to a default value just because I can. That's technically optional. Here are the attribute specific parts we need to focus on. Observed attributes is literally just an array of the names of the attributes we want to actually do something with potentially in our component. When those attributes change, when they get set to a value of some sort, like Nolan and Irk, this function will run attribute change callbacks. The attributes have changed in value from X to Y or whatever. For the most part, when you're building your sort of small-ish web components, you'll copy this method and paste it into your web component and just leave it as is. That kind of does the boilerplate stuff you need to do to start having attributes in your web component. And then that one you'll copy and paste, and you'll just change that part to whatever the names of the attributes are in your component. And down here we have connected callback. It's got the this.text content thing, just like we saw previously. And in this one, I've got some backticks, so I can use the handlebar style notation here. This.first name, this.last name. Those are the names of my attributes, first name and last name. And when that renders out on the screen, of course, we get this. And there's my attributes being drawn on the screen. Actually, let me show you one more thing in that demo while we're here too. I'm going to go open tab. And if I go view source, you can see it shows that it is a hello world tag with those attributes being passed in like so. So it's treated in the browser just like any other tag. Web components are what they call first class citizens. The content of them and how they behave in your browser is the same as any other tag, div, paragraph, table, and so on. If I right click on that and go inspect element instead of view source, you can see that it still does have the actual name of the web component in there. And we'll get that in a little bit more detail as well in some upcoming demos. All right, so there's our attributes. Let's look at multiple instances of an HTML web component. Go back here, close these files down. Multiple instances looks pretty much like you would expect it to look. Here's my hello world.js file. It is identical to the last one we looked at. This is the same as our attributes demo. On the HTML side, I'm simply calling that web component 4 times instead of just once. So what we should get is, actually I lied, there's one tiny difference in this one than the last one. I have wrapped the text content in div tags. So it's not just blocks of text. Now I now have an HTML tag inside my web component that we're using. And then we have the 4 instances of it over here. So now let's load that up in the browser and see what happens when we have 4 of them in a row with the div tags inside. I should get 4 divs, John, Paul, George, and Ringo. And we kind of got that, but the div tags did not get rendered as actual div tags. They got expressed as plain text and escaped onto the screen instead of being treated like actual div tags. So why is that happening there? A couple of things. If we're drawing just plain text on the screen, we can use this.text content, which is what we did in the previous 2 demos. If we want to use HTML tags inside our web component rendering, we have to use this.inner HTML instead of this.text content. So if we go back to our JS file and change it from, I'll just do it this way, this.text content to this.inner HTML, copy, paste, save, and reload. Now it renders everything properly on the screen. And I'll go view source. So you can take a look. We have 4 hello world tags. Check this part out though. Since we have inner HTML happening there, let's see if anything is different in this demo. Yeah, check this out. So we have these little triangles showing that we can expand out the web component and see what's inside them. And now inside them, we can see there's a div tag inside my hello world, rendering that content on the screen. And that's true for all 4 of these, of course. There's divs with all the individual stuff inside each of these. Close that down. So one other thing we might want to do, now that we're getting a little bit more involved with our web components, we have text, we have HTML, we have some CSS that's making the text green and larger in size, and I think adding a courier font to it. The more moving parts there are in your web component, the more it might be nice to just follow best practices and encapsulate all of that stuff inside your web component in one place, so that if I have a chunk of JavaScript in my web component called, let's say, favorite color or whatever, other chunks of JavaScript or other chunks of CSS cannot affect the CSS and JavaScript inside my web component. I want it to be a safe, compartmentalized thing. And that is where an item called Shadow DOM comes into play. It just helps us kind of wrap our web component in its own isolated spot so that it is less likely to be affected by things elsewhere happening in other chunks of code in the browser. All right, so the way we do Shadow DOM is you add a line of code, this.attach shadow, to your web component. There are 2 modes you can use Shadow DOM in, open and closed. Open just means, yes, other chunks of JavaScript can manipulate things inside my web component. And closed means No, they cannot be accessed that way. It's just a self-contained web component, a little bit more locked down in what we're trying to do. So with that, let's take a look at a Shadow DOM demo. There's our multiple instances one. And now Shadow DOM on the HTML side is exactly the same as it was before. Here's our 4 instances of the web component. Here's my JS file, a couple of differences in here. We have the same attribute stuff as we did previously, so nothing different there. Same constructor thing as we had before. Here's the part that's different. Down here in our connected callback, we now have this this.attach shadow set to closed mode, saving that to a variable. And now I'm saying shadow.innerHTML instead of this.innerHTML like we saw in the previous demo. And inside here, I have my own style block and my HTML markup all in one contained space. You'll notice that in my CSS, we have :host as the selector. That is the same as whatever the name of the current web component tag is. So instead of saying hello-world, I can just say :host, and it knows that this is the same as whatever the name of my web component is. And now all of our CSS is in the web component, and our HTML and our text is all in here. And now when we go to run that in the browser, we don't have to change anything on this side. But back here, when we run it, we should get the exact same output on the screen here, and we do. If I go view source, it'll look the same here. And if I go view inspect element, you'll see a tiny little difference now that we're using Shadow DOM. So now when I expand out hello world, you can see this shadow root thing. And inside the shadow root, inside my hello world component, I have the HTML and text from before. And I also have my own style block here with the CSS properties that we're using inside our web component as well. So each instance of the web component has its own little self-contained copy of everything that relates to whatever we're doing in that web component. We don't have to worry about keeping the files separate. We don't have to worry about other chunks of code negatively affecting them and so on. Slots. Slots are a thing in web components that let you do this. You can make a web component called my tag, and then you can have something between the opening and closing tags of your web component. So it works just like, a paragraph tag, for example, in your web browser. And slots are pretty easy to deal with. On the HTML side, you simply do what you would expect. Open web component, close web component, put whatever combination of text and HTML you want in between the tags. And then in the JavaScript side of things, most of it's exactly the same as it was before. Here's my constructor, my attribute stuff. That's all identical. The only difference is now we have this slot. And wherever that open slot, closed slot thing is, that's where this is going to render when your web component is drawn on the screen. Let's take a look at that in the browser. And slots look at this. Open it up. And there's hello, Pete Best in italics, just like we expect. Welcome to CF Online Summit. I'll go view inspect element. We'll take a look at how that looks down here. Hello world. There's my shadow root. And inside my shadow root is my style stuff and my div stuff. And there's my slot right below it with those things. If I expand out the div, you can see hello, and then the slot goes like that. So you get some extra detail about where the slot is being used in your inspect element tools down here too, just to give you more detail about where that stuff is happening at. Just close that. All right, those are the basics. Let's look at a somewhat more real world use for a web component. We've all had to write delete buttons or cancel buttons or things like that in our apps. And of course, you usually write some sort of JavaScript confirmation dialog attached to that saying, did you mean to click that? Are you sure you want to delete that user? Whatever the thing is. So we end up copy and pasting those chunks of JavaScript over and over to all the different delete buttons in our app. Kind of becomes repetitive. We're violating the DRY principle when we do that. Not a good use of anything. A way to solve that problem would be to build a confirm button in a web component. Let's take a look at that over here. So confirm. So here I have a web component called confirm button, and I simply pass in an attribute confirm URL and point it to some file that I want to run after this confirm is processed. And they say, yes, I really want to do that. I'm drawing delete file on the screen. The contents of that look like so. I simply moved some of the initialization stuff up into the constructor. so here's my shadow DOM thing from before. I'm now making a new button element, saving it to a variable, and putting a slot inside there. That's just a way of letting me draw text on the button from inside my web component, and then attaching that button onto the shadow DOM inside my component. We're interested in an attribute called confirm URL. And then in connected callback, we say, okay, anytime somebody has clicked this thing that we're dealing with, specifically the button inside our web component, run a method called do confirm click. That's down here. And this is basic JavaScript. There's nothing really web component specific in here. Just if you confirm, are you sure you want to do that? Then go ahead and redirect the user to whatever the confirm URL was that we gave them when we called the web component. And if they said, no, I do not want to continue to return false, just like you would any other chunk of JavaScript. So now if I go back here and I run my confirm demo like so, I click delete file. Are you sure you want to do that? Cancel it, leaves me right where I am. If I click delete file, are you sure you want to do that? Yes. It does in fact move me over to success.cfm as I expected to. So now I have one chunk of reusable code for all of my delete button sort of functionality in the app, rather than copy and pasting chunks of JavaScript everywhere. That being said, of course, always do more validation on the server side after you do the JavaScript stuff to provide a smooth user experience. You still want to double check that files were or were not supposed to be deleted or modified or whatever you're doing on the server side, because hackers can turn off JavaScript. That's a demo and conversation for another day, but just want to briefly give you a reminder of that. Another thing we often have to build in development is slideshows, where you have your photo gallery and you've got 20 photos, you have to cycle through them. We're constantly looking for photo gallery plugins, maybe for jQuery, or photo gallery libraries that people have written that we can just grab and put on the web. Those are often fairly large and bloated because they're meant to be everything for everyone. If I don't need 90% of the features in a photo gallery slideshow thing, why should I have to pay the download expense for with all of my users to load all those features that I'm never going to actually, deal with? You can build yourself a real quick slideshow demo in in web components that works like this. Slideshow, open it up, and I have previous and next buttons, and I can just cycle through the images. Let's take a look at the code for that. Close down some of these so I don't get confused. Slideshow, and on the HTML side, that's not the right demo. That's the right demo. On the HTML side, I've got an open and close slideshow web component tag, and I have some plain image tags inside it. I've got a little bit of style info up here just to make the images in the photo gallery render at a consistent size. This is not web component specific. This is Nolan was lazy and did not resize his JPEGs properly thing. So in my slideshow component, it looks like this. And full disclosure, this is pretty heavily stolen and modified from a demo that Ray Camden gave on his blog a while back. His probably had to do with cats, I'm going to assume. And I've modified it to be this thing with guitar players. Thank you, Raymond. If you are not familiar with his website, please check out his blog. You'll get a lot of really good value out of there. So anyway, here's our slideshow component. Constructor has got some boilerplate stuff in it. I'm going to find the total number of images inside our slideshow. So these here. Save that to a variable. I'm going to build out the slot where my image is going to go. And then I have a couple of buttons for previous and next, so we can cycle forward and back through the images. I'm just going to get some variables so I can reference the previous and next buttons later, add that stuff to the DOM. And now I have these, hooks in here for when somebody clicks either the next button or previous button, run my next image or previous image methods. And then I've also got a method called update image down below. We'll look at those three now. So next image and previous image are both basically just advancing forward or backwards through the set of images we have inside our web component. That's all they do. And then both of them call update image when they're done. An update image simply looks through all of the images we have and figures out what the current one is we're displaying on the screen. It does a little bit of CSS to make that image visible and hide all of the other images. And that's it. None of this is web component specific. This is basic JavaScript. There's nothing fancy in there at all. So that's 50 to line. That's like 40 lines of code that's just vanilla JS. You could build even without a web component if you wanted to. The web component stuff is this little bit up here where we're just like adding, adding our previous next buttons with our slot, and then writing a little bit of code to say, okay, when those buttons are clicked, please do something. And there's the thing it does. And as we saw, it does in fact cycle through and draw our images on the screen like we expect. So now we have a fully working slideshow in under 100 lines of code. No extra giant CSS themes to download, no jQuery modifications or extra jQuery files you have to include. A little bit of vanilla JS and you're off to the races. All right. Now, how do we combine this with Cold Fusion and get stuff to happen? A couple of different ways you can do that. We'll look at 3 or 4 different demos of how they work. None of the ways you use web components require rewriting your entire CFML code base. If you have anybody on your team or anyone you've talked to that has said, oh, I want to use web components, but I don't want to have to rewrite chunks of my code. If they thought they had to rewrite chunks of their code, they were misinformed somehow. You do not have to do that. You can drop web components in to whatever small, medium, or large spots in your app you feel like using them. The rest of your code should not have to change in any way. They are self-contained modules. They don't care what the rest of your code looks like. You should be all set. And with that, let's take a look at a simple demo of how to drop web components into a Cold Fusion page. So here I have an index.cfm file. This is the first one we've had that was not .html. It's a CFM file. And I've got a simple Cold Fusion array of structs at the top of that file with somebody's name, the band they're in, and a link to the photo of that person. My web component in this case is called guitar player. And it's pretty straightforward. So just a constructor setting some default values. The attribute stuff is identical to before. We don't have to look at that again. Connected callback, a little bit different technically than what we've seen previously. Just I have some new CSS in here to style my web component, how I want this component to be styled, but there's nothing web component-y specific in there. A little bit of HTML. I'm going to draw a div with some spans and a div inside it. The div will have the person's name, the band they're in, and then an image tag pointed to whatever that JPEG is that I gave in this array. So I can use CF loop and loop over these guitar player web components, and they'll all render out on the screen the way we expect them to. Let's take a look at that demo. That's number 8. This, and here's my individual web components. 1, 2, 3, 4, 5. There's all the stuff. And I can right click on one and go inspect element, and you'll see it does in fact look like a guitar player web component with the shadow DOM stuff baked inside it, just like you expect it to. Same as the other previous demos. There we go. And the web component, you'll notice in this situation, there is no Cold Fusion specific code in here. This dropped in and just worked. I didn't have to do a CF include anywhere, didn't have to add pound signs in here anywhere specific. It just works. Over here on the CFM side, it just works. Include your JS file and call the web component like you would in any other spot. All right, let's close that one. So often what you'll do is you'll have a web component and maybe you want to talk to an API on the back end and consume data that way and get data from your Cold Fusion server out of a SQL query or whatever. You'll probably hit an API URL and return JSON back. JavaScript, not just specific web components, but Angular, Vanilla JS, Svelte, Vue, React, whatever JavaScript framework comes out next year or 3 years down the line, none of them care what your backend server is written in. If you've ever had a teammate say, we cannot use this JavaScript library because it is not compatible with Cold Fusion, again, they were misinformed. All JavaScript libraries are compatible with Adobe Cold Fusion. All JavaScript cares about is that the URL feeding it data feeds it valid JSON. You can feed JSON from Cold Fusion and 50 other things. They'll all work the exact same way. So how do you get JSON back from your Cold Fusion server? Cold Fusion has built-in API features for building your own API with Cold Fusion. You can use various combinations of those. We're not going to get into the details of those in this demo. There are a variety of videos and other reference materials out on the web, though, for how to do that with Cold Fusion. If you're using Coldbox REST, or I'm sorry, if you're using Coldbox, there is a REST API template that will let you scaffold out an API that returns JSON pretty quickly by typing a couple of command box commands and spinning that up. Coldbox itself, outside of just the REST API template, has some features where in your Coldbox app, Instead of returning HTML for a page, you can have it return JSON. Framework 1 has a similar feature. There's a tool called Taffy.io. If you're not in an MVC environment like Framework 1 or Coldbox, you can use Taffy. It's a free open source tool that is really easy to use to build out APIs. If you have an older legacy CFML app that's got a lot of spaghetti code that's kind of long in the tooth, you can still get that to return JSON. There's just a little bit more code you would have to write in some spots to get the JSON out to the screen. We'll look at a couple simple demos of how to do some of that right here. So demo number 9 looks like this. Here's my index CFM file. You'll notice that this one, the web component is called guitar players, plural, not singular. So we're not looping over anything in this example. Let's take a look at what the JavaScript looks like. So our constructor and attribute stuff is exactly the same as before. Here's the new stuff we have down below. Connected callback, shadow DOM, inner HTML. Where is my thing? Just log it. Oh, come on. I'm looking for a demo, and did I grab the wrong file? Guitar players. I was in the wrong file. My apologies. All right, guitar player is plural. Here we go. So constructor is some default stuff. Here's the new part we want. Find Rockstar's API. It's going to use fetch to go out to our legacy API. So API legacy.cfm. I'll look at the details of that in just a minute. We're going to return the data from that into a variable called results, turn that into valid JSON, and hand that back to whoever called this find Rockstar's API method. We have our attribute stuff. It's exactly the same as it was before. Here's our connected callback where the magic happens. We're calling find Rockstar's API right there, save it to a variable. And then down here inside my shadow DOM stuff, I'm simply looping over what came back in that array, building up div tags with the contents inside them, appending those to each other, and storing that back in my shadow inner HTML, which is what the stuff is that gets rendered out onto the screen. So let's take a look at what we're doing here inside legacy.cfm and make sure there's nothing fancy or no magic happening in there we have to worry about. So here's my legacy CFM file. It's got a cold fusion variable in it, similar to the one we saw before. This is an array of structs. And I'm simply saying I'm going to output some content to the screen. It will be JSON in format. We're going to serialize that variable and turn it into JSON so that when I hit this URL, it looks like this. I'm going to go here, copy and paste. And I'm going to go API legacy. And then, of course, if I hit that URL straight, I get back valid JSON on the screen. So let's load that up and see what happens if it doesn't work properly here in our browser. And sure enough, there it is. It fetched that data off of our API, returned things to the page, to the browser, how we expected. All right, so let's take that demo one step farther. Here in my API, I've got another variation of it. I'm using a component in this case. Notice it's one component. There's no Taffy.io stuff in here. There's no Framework 1 or Coldbox. It's just a one-off CFC. So you do not have to have a full-blown framework to make this work. I have a component with a method in it called getGuitarists. The method is set to remote. That's the important part here. So when I have a remote method, I can call this method actually from the URL. This is one of my favorite features in Cold Fusion. Instead of hitting a CFM page like that, I can turn this off. And I can go hit a URL like this. I can say musicians.cfc method equals get guitarists and run that method. Let's do that here in the browser. I'm going to go here and musician.cfc method equals get guitarists, and it ran that method that returned all the guitarists to the screen. Now that worked, but this is not valid JSON. JSON should have the angle brackets around it and look like, a JavaScript variable. In my browser, I can simply add on and return format equals JSON. And now that data came back as valid JSON. Now, yes, I have a URL here that I can just add that return format JSON. It'll call a method in my component. It will return valid JSON back to the browser for me, or back to the client app, or whatever we're doing. Do not take this back to your bosses and tell them Nolan said all we have to do is return format JSON, and we have an API we can sell to our customers. Yes, technically this is an API. Yes, this is returning valid JSON. Yes, I'm going to use it in these demos. Before you let the entire planet have access to all of your data through an API, you still have to be mindful of things like security and architecture and take care of those before adding this kind of feature into your app. But the takeaway here is if you use components, you can get a heck of a lot more functionality out of your app than if you're using older things like CF includes and .cfm files when you really should not be using those. So I can take that same syntax here and return format JSON. Back here in my JavaScript, I can do that same thing. Musician.cfc, method equals get guitarist, and return format equals JSON. Save that to a variable. And that's the only thing I did. I commented out our legacy line of code. I turned on this version that uses a CFC with that remote keyword inside it. And now when I go back here and load up this demo, we get the results from our CFC. Very, very little code had to change in our application to do that. If you have a Framework 1 app, put your Framework 1 URL in there and follow whatever the format is for that. If you have a Coldbox or Coldbox REST API or a Taffy or whatever else, it's the exact same thing. Put a fetch in here, put the URL in that matches your app. None of the rest of your web component has to change. It'll all just work. All right, let's close this demo down and that demo down. Last demo. Another way you can get stuff back from the server, of course, is using our old friend CFHTTP. So I can use those same URLs that we had inside our web component. If you want to keep your ColdFusion stuff outside of your web component and separate them for different design reasons, you can do it this way. Call the CFHTTP, hit the URL, save the results into a variable, deserialize the contents of that variable and save it to a ColdFusion variable, and then loop over the results. And in this one, we have our guitar player singular web component from before. There is no fetch API stuff in here. This is a plain generic web component, just drawing stuff on the screen that gets passed in as attributes, name and band. Those are passed in here, name and band. We're looping over them and drawing them on the screen like so. And that one worked. And there's our web component with CFHTTP rendering on the screen. I'm going to turn that URL off. And I'm going to turn on this one that's doing the same thing as our previous demo, where I'm hitting the CFC directly, calling the method getGuitarist, adding return format equals JSON on there. And then also inside that component, there was an optional argument called genre. If I give it a genre, it will actually filter the results by genre as well. And we are doing that in this case and saying, just get me back all of the metal guitar players instead of everything. I'll load that up in the browser like so. And now we get just the metal guitar players back. If I go in here and I change that to, what were some of the other options? Let's go alternative. Metal equals, genre equals, alternative, save, reload, and then you just get back the alternative ones. And of course, if I take that out, I will get back all of the data. So you've got a handful of different ways you can combine your web components with your ColdFusion application, depending on whatever state your code is in or whatever type of design architecture you're going for with your stuff. Web components are super useful by themselves. If you have a legacy app and you're trying to migrate it into something a little bit more modern with like a JavaScript front end like React or Alpine.js or something, web components are a great way to sort of incrementally move your code separated out that way to have your ColdFusion stuff on one side and your JavaScript front end on the other. You can just pick specific moving parts, if you will, of your front end and turn those moving parts into individual web components just as a case-by-case basis. You don't have to do them all at once. And then, of course, once you have all of your things in web components, that makes it really easy to port the rest of your app over to a single-page application like React or Angular. Makes it really easy to use that stuff in mobile frameworks as well, since a lot of mobile framework stuff is JavaScript-based too. And of course, these are compatible with all of the front-end frameworks, like I said, React and Vue and everything else. And we've seen several demos of them working in .cfm files with no problem. So there's a little bit of syntax you have to do and a handful of lifecycle methods with them. As we saw, the connected callback is required. The constructor is not technically required, but you really should have a constructor in any OO stuff you do. The rest of them are either a boilerplate you might add or they're things you can skip. It just depends on what you're doing with your web component. Yes, you can combine these with other JS libraries like photo galleries or jQuery or whatever other stuff you have out there. Will they work or not depends on how the quality of the code is in that library and the quality of the code in the web components you write. So as long as everyone is playing nice and following good standards, everything should just work for you, without too much trouble. Brief reminder again, the attributes and the tag names have to be lowercase. Hello dash world, all lowercase letters. First name, all lowercase letters. Technically, that is a bug in the spec. They're looking to change that at some point in the future so you can have mixed case components and such. I don't know what the status is on getting that fixed. You can use attributes to pass data into your web component, as we saw. You can use a thing called custom event to pass data back out to the calling world if you need to do something like that. As I mentioned before, since you have to have a hyphen in your component name, come up with a naming convention. I run south of Shasta, so I might build like, SH dash and then the component name, for example. You'll notice that I skipped form elements, input tags, and select boxes and things like that, or select dropdowns rather. That's because they can be a little bit trickier to deal with in your components. It's not impossible. It's just kind of its own topic a little bit. If you want to check those out, look for a thing called the form data interface or element internals. There are also a couple of JS libraries people have made that will help make doing the web component stuff a little more easier with input tags and such. SEO. You'll notice back in our slideshow, the image tags are still image tags. Don't make a web component that replaces an actual HTML tag that is part of your content, especially if that content is something you want Google to pick up. I want Google to see the 5 images in my slideshow gallery. That is content that is going to help my site rank higher or lower in the search engine results. The only thing I made a web component is the actual web component functionality, the previous and next buttons and the little image counter saying I'm on picture number 2 of 5. The actual content, leave it alone for SEO and accessibility reasons. I guess you could replace it, but you're going to just, destroy your SEO results. So don't do that. If you have a lot of web components, maybe you have 20 or 30 of them that you're using, yes, that could end up meaning 20 or 30 .js files. Typically, I will make one JS file for one web component. If I have 2 or 3 that are related and kind of small, maybe I'll put all of them into one JS file to cut down on the files. If you do end up in a spot where you have a lot of JS files, whether it's web components or other things, you can always use a tool, a minifier of some sort like Webpack, to smush all those into one minified JS file, and then you have better performance because you're downloading one thing instead of 40. And of course, always put your JS files at the bottom of your HTML page. Don't put them in the head. That'll make your page render a little bit faster, whether it's web components or not. Just that's a better practice for optimizing page loads. As I mentioned, Ray Camden's blog is a really good spot to check out. He's got a bunch of demos on web components, on Alpine.js, a bunch of things involving cats, lots of fantastic content on Raymond's website. Web Components in Space is a YouTube channel made by Ben Farrell. Ben is another Adobe employee, and he's got, I don't know, I'm going to say 15 or 20 or so, at least, web component videos up there that are worth checking out. Unicorn Utterances is a blog made by my friend here in Sacramento, Corbin. He's got a bunch of demos up there of web components and also things related to various front-end frameworks, React and Vue, and how they all interact with each other and stuff. That's a really good, easy to understand blog site with a lot of really good content. These last 2 are basically websites for like just general promotion of using web components. And I believe this one actually has a set of tests they run anytime one of the big JavaScript frameworks comes out with an update, React or Vue or whatever. I think it's this one. They run a set of unit tests against that framework to make sure that the framework update did not break web component compatibility. And if, let's say, React, for example, did break something, these guys tell React, hey, you busted web components, you got to fix it. And they try to keep the framework people on top of making sure that that's all compatible. If you like web components and want to look at doing more of this, just like in CSS, we have Bootstrap, which is a nice library that solves a lot of common problems in CSS land for us that you can use. Lit and Stencil and Shoelace are web component libraries that solve lots of common problems people have that they want to build web components for. And these are worth checking out. Everything I said at the beginning of this demo about how web components are vanilla JS, they do not need a build step of any sort. You don't have to install NPM and that sort of thing. That is not true with lit or stencil. If you want to use either one of those, they do have a compilation build step sort of thing you have to do. You might have to install a couple node packages and do a couple of things differently in your build process. The trade-off might be worth it though. If lit or stencil solves problems that are very important to you, maybe it's worth a couple of extra steps in using them to get that trade-off. Shoelace, you can do it that way where you build it, or you can just use it as a JS file that you include in your app, just like you include Bootstrap or whatever, and it'll work just fine. So check those out. They might be worth adding to your app at some point. And there are also tons of other web component things that people have written that are on GitHub. Just go search for web components and you'll find a bazillion different demos that people are offering, or code repos that might do something for you. And with that, we've got, I think, about 9 minutes left for questions. This is contact info for me if you'd like to chat with me more about this stuff or other projects or what have you. And I will try to check in the Q&A chat and see if there are any questions that I can answer while we're sitting here with the last couple of minutes. Let's see here. Lots of comments in here. Let me scroll up here and see what's going on. Q&A. Here we go, Q&A. Let's see. VS Code. Can you stylize a web component? Use CSS classes IDs? Yes, you can stylize a web component. We did have CSS in a couple of the demos. I didn't get into anything advanced style-wise, but yes, you can write whatever normal CSS you have, and it'll all work just fine inside your web components. Oh, I see you got that answered. Nick says, is there an accepted standard or best practice for exposing variables like a value from a custom color picker or events? Yes, exposing variables back to like the calling chunk of code. I think the recommended practice would probably be using an event and broadcast the thing that changed out to the outside world using an event, just like you would on click or on mouse over or any other custom event in your application. Is there a good way to separate HTML from the rest of the component? Most of the examples I see bake the HTML into a string literal or JS file template. Is there a good way to do it? You could do, I guess technically, yeah, you could have separate files and then use some sort of build process like Webpack or Gulp tasks or something to combine them together at some point. You could also maybe look at using the HTML template tag to sort of templatize some of your Vue stuff separately from your JS. It just depends on what you're trying to do, I guess. Rama asks, are web components secure? Support content encryption, decryption for posting response. Web components are as secure as you make them to be. So they are vanilla JavaScript. So by design, they are just as secure as any other JavaScript that you write in your application. So if you write a chunk of code, whether it's a web component or JS or Cold Fusion or anything else, if that chunk of code has a SQL injection attack in it or a cross-site scripting attack in it, then the code is not secure. That is not the fault of a web component, nor is that the fault of Cold Fusion if it happens on the back end. That is the fault of whoever wrote the code, did so and just did not follow best practices and left a security hole in there. So just be mindful of, all the same security best practices when you're writing web components that you're familiar with when you're writing any other chunks of code. And I have a $50 raffle to give away to somebody. In my head, I thought I would give it to the best question that someone asked in here. And Rama, I think I like your question the best of that, just because security is always a thing we should be mindful of. So Apuva, if you could coordinate with Rama and get the raffle prize over to them, that would be awesome. And now let me figure out how I close this window and see if there are any other questions in the other chat. Well, I've got a couple more minutes here to hang out. Let's see. Performing arts. Lots of chat about Eddie Van Halen. I like it. And COBOL. Yep, I actually had to take a semester of COBOL in college. That was the last time I ever looked at COBOL, was after that class was done. Really, Rick and back. Yes, Rick Cameron's got a demo on web components up on that YouTube channel. I think I've got one on my South of Shasta YouTube channel as well that's got some similar content in it. Don't see any other questions